Q61. A data engineer is trying to access a table named new_table in a Databricks workspace, but encounters a permission error. They need to request access from the table owner, yet they are unsure who owns the table. To proceed, the engineer must determine the owner of new_table using available tools in the environment. Which method can the engineer use to find out who owns the table? A. Check the Permissions tab in Data Explorer for the table. B. Assume ownership details are not available for the table. C. Locate the owner field in the table's page in Data Explorer. D. Look for ownership details in the table's page in the cloud storage solution. The correct answer is C. Locate the owner field in the table's page in Data Explorer. Why this is correct? In Databricks, Catalog Explorer, formerly known as Data Explorer, is a central place to view metadata for secureable objects like catalogs, schemas, and tables. When you navigate to a specific table's page in Catalog Explorer, the owner field is clearly displayed in the Table Details/Metadata section, often on the Overview or Details tab, allowing anyone with visibility into the schema to see who owns it, even if they don't have read/write permissions for the data itself. Why the other options are incorrect? A is incorrect. The Permissions tab shows which users or groups have been granted specific privileges, like select or modify, on the table, but the object's absolute owner is explicitly listed in the main metadata/overview fields. That B is incorrect. Ownership details are absolutely tracked and available via Unity Catalog or the Hive Metastore. That D is incorrect. Cloud storage solutions, like AWS S3 or ADLS Gen 2, only see the underlying data files, Parquet/Delta, and the IAM roles accessing them. They do not map or display Databricks-specific workspace table ownership. Q62. A data engineering team is designing a Medallion architecture for a retail analytics platform. They begin by ingesting raw data from multiple sources and want to organize it into bronze tables as the first layer of their pipeline. To document the transformation process, they need to describe the relationship between bronze tables and raw data. Which statement best explains how bronze tables relate to raw data? A. Bronze tables store a reduced subset compared to raw data. B. Bronze tables contain more truthful data than raw data. C. Bronze tables organize raw data with a schema applied. D. Bronze tables present a rougher version of the data than raw input. The correct answer is C. Bronze tables organize raw data with a schema applied. Why this is correct? In a Medallion architecture, the bronze layer acts as a raw ingestion point. Its main purpose is to take raw data from source systems, like JSON logs, CSVs, or API dumps, and capture it in an append-only format while maintaining full historical fidelity. By loading this data into a Delta table, you structurally organize the raw data and apply a schema defining columns and data types, so that downstream processes can easily query it using SQL or data frames. Why the other options are incorrect? A is incorrect. Bronze tables generally store the complete history of the raw data without filtering or dropping columns. Data reduction and filtering happen in the silver layer. B is incorrect. Bronze tables contain the exact same data as a source, meaning any untruthful, corrupt, or missing data from the raw input is preserved as is. Cleaning and validation happen later. D is incorrect. Bronze data isn't rougher than the raw data. It is functionally identical in content, just structured into a queryable table format. Q63. In a hospital's analytics environment, patient data is stored using Delta Lake. A data analyst needs to examine the state of the patient_records table as it existed 2 weeks ago, before recent updates were made. The data engineer must enable access to that prior version without disrupting the current table state. What approach should the data engineer take to allow the analyst to query that specific prior version? A. Truncate the table to remove all data, then reload the data from 2 weeks ago into the truncated table for the analyst to query. B. Use the Delta transaction log to find the version from 2 weeks ago, then either share the version AS of reference or export that version to a new Delta table. C. Apply the restore command to revert the table to its 2-week-old state and let the analyst query it. D. Run the vacuum command to delete versions older than 2 weeks, leaving the analyst with the latest version to query. The correct answer is B. Use the Delta transaction log to find the version from 2 weeks ago, then either share the version AS of reference or export that version to a new Delta table. Why this is correct. One of Delta Lake's core features is time travel, which is powered by the Delta transaction log, _Delta_log. This log keeps track of every commit made to the table. To view the data exactly as it looked 2 weeks ago, the analyst can query the table using the version AS of or timestamp AS of syntax. This allows the analyst to see the historical state simultaneously, while other processes continue writing to the current state, ensuring zero disruption to production table. SQL. Example of how the analyst would query it directly. Select asterisk from patient_records timestamp AS of July 4th, 2026. Why the other options are incorrect. A is incorrect. Truncating and reloading the table will completely destroy the current production data and cause a massive disruption to anyone using the live environment. C is incorrect. The restore command is a destructive rollback tool. It would revert the live production table back to that old state, wiping out all the updates made over the last 2 weeks. D is incorrect. Running vacuum actually deletes old data files that are no longer needed by the current version. Doing this would permanently destroy the historical data from 2 weeks ago, making it impossible for the analyst to query it. Q64. A data engineer is designing a Medallion architecture in their Lakehouse platform to support scalable analytics. They want to understand the relationship between silver tables and bronze tables to ensure proper transformation logic. The goal is to confirm a consistent truth about how aggregated and raw data are handled across layers. Which statement regarding the relationship between silver tables and bronze tables is always true? A. Silver tables hold a less clean and less refined version of data compared to bronze tables. B. Silver tables include aggregated records, whereas bronze tables maintain unaggregated data. C. Silver tables store a greater amount of data than bronze tables. D. Silver tables store a smaller amount of data than bronze tables. The correct answer is D. Silver tables store a smaller amount of data than bronze tables. Why this is correct. In the Medallion architecture, data flows from bronze raw ingestion to silver, cleaned, filtered, and conformed. Because silver tables are typically deduplicated, filtered for quality, and stripped of bad or corrupt records, they naturally contain a smaller total volume/amount of data than the cumulative, append-only raw data stored in the bronze layer. Why the other options are incorrect. A is incorrect. It is exactly the opposite. Silver tables hold a more clean and more refined version of the data than bronze tables. B is incorrect. While bronze tables do maintain unaggregated data, silver tables do not focus on aggregations. Aggregations, business logic summaries, and KPIs are characteristic of the gold layer. Silver is meant for clean, enterprise-wide row-level data. C is incorrect. Because bronze stores every single raw record historically, including duplicates, historical changes, and bad data, while silver filters these out. Silver will possess fewer overall records than bronze. Q65. A data analyst is preparing a report for the business team using SQL. The source table contains transactional data in a long format, where each row represents a unique combination of customer and month. To make the report easier to read, the analysts want to convert the table from a long format to a wide format, where each month becomes a separate column. Which SQL keyword can be used to convert a table from a long format to a wide format? A. Transform. B. Pivot. C. Sum. D. Convert. The correct answer is B. Pivot. Why this is correct. The pivot clause in SQL is specifically designed to rotate a table-valued expression by turning unique values from one column into multiple individual columns, effectively converting data from a long format to a wide format. It allows you to run aggregations over these shifted columns where necessary. Why the other options are incorrect. A is incorrect. Transform is used in some SQL dialects, like Apache's spark.sql, for applying a custom expression or lambda function to elements within an array or map, but it does not reshape table rows into columns. C is incorrect. Sum is a standard mathematical aggregation function. While it is often nested inside a pivot statement to aggregate data, the function itself cannot alter the structural orientation of the table from rows to columns. D is incorrect. Convert is typically used to cast data from one data type to another, such as changing a string to a datetime, not for modifying structural table layouts. Q66. A data engineer is working in a collaborative Git environment. After pulling the latest changes, they want to synchronize their local repository with the remote one to ensure they have the most up-to-date code base before continuing development. Which Git operation should they perform to achieve this? A. Clone. B. Pull. C. Merge. D. Push. Q67. A retail data engineer is tracking data quality using a Databricks SQL dashboard that flags stores with 0 sales. To ensure timely action, they want their entire team to receive a messaging webhook alert whenever the count of such records exceeds 0. What is the most suitable method to configure this notification? A. Create an alert using a custom template. B. Configure an alert that sends updates to a new email group. C. Set up an alert that triggers only once when the condition is met. D. Configure an alert with new webhook alert destination. The correct answer is D. Configure an alert with a new webhook alert destination. Why this is correct. The user explicitly states that they want their team to receive a messaging webhook alert, such as a notification pushed to a Slack channel, Microsoft Teams, or a custom internal endpoint, whenever the condition is met. In Databricks SQL, alerts can be wired up to various alert destinations. To route the message out of Databricks and into a team chat or messaging tool via webhooks, the engineer must create and configure a new webhook alert destination. Why the other options are incorrect. A is incorrect. While creating a custom template changes what the message looks like, it doesn't solve the problem of where the message goes, routing it to a messaging webhook. B is incorrect. Sending updates to an email group sends a standard email notification, which does not fulfill the requirement of triggering a messaging webhook. C is incorrect. Setting the alert to trigger only once dictates the frequency of notification behavior, but it does not address configuring the destination needed to send a webhook. Q68. A data engineer reviewing an existing Delta Live table's pipeline notices the following SQL logic used to define a new table. Create streaming live table loyal underscore customers as select customer underscore D from stream live.customers, where loyalty underscore level equals high. They want to understand the purpose of the stream function in this context. What does its inclusion indicate about the source table? A. The stream function is incorrectly used and will result in a syntax error. B. The function is used because the target table is defined as a live table. C. The function is required because the source table is a streaming live table. D. The source table is built from a structured streaming PySpark data frame. The correct answer is C. The function is required because the source table is a streaming live table. Why this is correct. In Delta Live Tables, DLT, using SQL, if you're defining a streaming live table which processes data incrementally rather than recalculating the entire table from scratch, any dataset you read from must be wrapped in the stream function. Including from stream live.customers tells the DLT engine to read the customer's table as a streaming source, meaning it will capture only the new or appended rows incrementally since the last pipeline run. Why the other options are incorrect. A is incorrect. This is completely valid in standard DLT SQL syntax for incremental data pipelines. B is incorrect. If the target table were a standard non-streaming live table, you would query the source table directly without using the stream function, e.g., from live.customers. D is incorrect. While DLT uses Apache Spark structured streaming engine under the hood, the stream function in a DLT SQL script specifically points to a DLT dataset, live.customers, not an external PySpark data frame created in a separate notebook environment. Q69. A data analyst has written a SQL query that reads from a Delta table to validate customer transaction records. To automate data quality checks, the engineering team who works in Python needs to run this query and process the results using PySpark. What operation should they use to execute the SQL query and work with the output in their Python-based testing framework? A. Select asterisk from sales. B. Spark.delta.table. C. Spark.sql. D. There is no way to share data between PySpark and SQL. The correct answer is C. Spark.sql. Why this is correct? In PySpark, the Spark.sql method allows you to execute any standard SQL query directly inside a Python environment. It takes the SQL query as a string argument, runs it against a catalog, and returns the result as a PySpark data frame, which the data engineering team can easily manipulate, assert against, or process inside their Python testing framework. Python. Hashtag example how they would run the query in Python. df equals spark.sql. Select asterisk from customer underscore transactions where validation underscore status equals failed. Why the other options are incorrect. A is incorrect. Select asterisk from sales is pure SQL syntax. Writing this directly into a Python file or a Python configured notebook cell without a wrapper method will result in a Python syntax error. B is incorrect. There is no standard Spark to Delta.table API method in PySpark. To load an entire Delta table directly as a data frame using a PySpark programmatic API, the correct syntax would be spark.read.table, table underscore name. But this wouldn't allow them to execute the custom written SQL query directly. That D is incorrect. Data sharing between PySpark and SQL is seamless. They both operate on the exact same underlying Spark session and catalog data structures. Q70. A data engineer is prototyping a lightweight transformation task in Databricks involving minimal data volume and no distributed processing. To reduce resource usage and cost, they are evaluating whether to use a single node cluster for this task. Which of the following describes a scenario in which a data engineer will want to use a single node cluster? A. When they interact with small dataset during development. B. When they generate schedule reports that need fast refresh times. C. When they execute SQL queries using Databricks SQL. D. When they need scalability to handle increasing data volumes. The correct answer is A. When they interact with a small dataset during development. Why this is correct. Single node clusters in Databricks are configured with 0 worker nodes, meaning all computations run entirely on the driver node. This setup is ideal for development, prototyping, or exploratory data analysis when working with small datasets that do not require distributed processing. It significantly lowers resource usage and cost because you aren't paying for an entire cluster of virtual machines to process lightweight tasks. Why the other options are incorrect. B is incorrect. Scheduled production reports that require fast, guaranteed refresh times typically use standard multi-node clusters or automated job clusters to ensure consistent processing speeds and reliability under production SLAs. C is incorrect. Databricks SQL queries run on SQL warehouses, formerly SQL endpoints, which use specific architecture configurations optimized for BI workloads rather than standard single-node clusters. That D is incorrect. Single-node clusters lack the capacity to scale out across multiple machines, making them entirely unsuited for scenarios where you need scalability to handle increasing volumes of data.
If this video helped you clear up some data engineering concepts today, hit that like button and subscribe to Innova 8 Hub so you never miss our daily breakdowns. It really helps the channel grow. Please do not go anywhere. Jump into the next video, and I'll see you there.